Hi there, this is Teacher Kath and welcome to my channel. Hello to you. Now in this video, we are going to discuss about the Venn diagram concepts. Alright, so what is a Venn diagram? Well, a Venn diagram is also called primary diagram, set diagram, or logic diagram, which is a diagram that shows all possible logical relations between a finite collection of different sets. But of course, a Venn diagram is not only for mathematics. Some of your teachers or maybe reporters are using the Venn diagram to establish the similarities and differences of some concepts, right? So the Venn diagram depicts elements as points in the plane and sets as regions inside closed curves. So basically, we're using geometrical shapes. You may actually use any shapes, but in most cases, for the plane, which would represent the universal set, we will be using a rectangle. And for the subsets, we are going to use circles for the closed curves. Okay, so let's go. Now, let's try to illustrate the given. Here's a universal set with the elements 2, 3, 5, 7, 11, and a subset with elements 3 and 5. How are you going to put these elements inside these Venn diagram? So, please observe that here in your Venn diagram, the circle for set A is inside the rectangle for the universal set, which means your set A is contained in the universal set, which obviously should be the case because A is a subset, or the elements of A come from the universal set. So the first thing that you'll have to do is simply write the elements of set A, the innermost region of your Venn diagram. Simply write the elements 3 and 5. Okay, so there you have it for set A, 3 and 5. And then you complete the universal set. Since you already have 3 and 5, you only have to write the remaining elements of the universal set, but it should be outside the circle for set A, but still inside the rectangle for the universal set. Okay, so that's how it should look like. You have 2, 3, 5, 7, 11, the complete elements for your universal set, and 3 and 5 for the elements of set A. Always remember that when you're writing the elements in your Venn diagram, no element should be written more than once. No element must be written more than once. It's a no-no. Okay? So notice that you have here a 3, 5 and another 3, 5. It doesn't mean you have to repeat 3 and 5 in that rectangle outside the circle. Okay? So it should only appear once. I hope that's clear. Let's have another illustration. So this time, your universal set is 1, 2, 3, 4, 5. These are the elements. With your subsets M with elements 1, 2, and another subset N with elements 2 and 5. What you have to do is, if you can't work with the innermost or the centermost part of your Venn diagram, try to work on it step by step, or let's say one figure at a time. Okay, so I want you to focus on set M. Okay, so let's focus on set M first. What are the elements of set M? Okay, you may still probably use a chalkboard for this or a pencil so that you can still erase if we need to erase some elements. Okay, so we will write 1 and 2. Now, why did I put 2 right there? Because I know that if I now focus on set N, 2 still exists. See, 2 is still in set N as well as it is in set M. So it should really go there. And complete set N, we only have the element 5 left. So there you have it. 2 and 5 for set N. Since your subsets are complete, you now have to complete the whole Venn diagram by writing the remaining elements of your universal set. Naanatay 1, 2, and 5 So what remains, or say kulang, we have 3 and 4 na lang. So we write that outside these circles but still inside the rectangles. Okay, there you have it. Your universal set, 1, 2, 3, 4, 5. Complete. Set M, 1, 2. Set N, 2, 5. Okay. Now moving on to set operations using Venn diagrams. Well, I'm going to show you the regions in the Venn diagram that would tell you the answer if you're going to solve for or use some operations on set. Okay, so let's start with the union. So that is A union B. Earlier in our previous video, when we said union, that's the combination. That means you have to combine the elements of set A and set B. So if you're working with a Venn diagram, all you have to do is shade the answer for your union. And that would mean you have to shade everything. So there you have it, ladies and gentlemen. That is your A union B. All right. Let's now proceed to A intersection B. Okay, the intersection is where you find the common or you identify the common, say pareha nilang duha, when you're given the roster form of a set. But in the case of the Venn diagram, what you have to do to find the intersection is simply find the overlap. Where will set A and set B overlap? And obviously, that is this region. There. So the overlap part is your intersection. Okay. Next, for the set operation, we have the difference. Okay. So we have here A minus B. So that means what becomes of A if you remove B? We take B. That will be left. So of course, the answer is for the shaded region. This part of A, because this is taken as part of B. Okay, so that's A minus B. Alright. How about B minus A? Same process. That is what becomes of set B if you take or remove set A. So if we are going to remove set A, that's what we have left. Are the elements of the universal set that is not in the given set. So if you have a complement, that means what are the elements of the universal set that are not in this set? So we simply remove this set, and what remains of it is a complement. So let's shade the answer. Okay, there you have it. That is a complement. And finally, for another example for complements, okay, sorry for that. Okay, so for B complement this time, again, what's left of the universal set if you take away or remove set B? That's what's meant by B complement. So we're going to shade everything that is not in B. So that's definitely it. Of course, we included this part of A since that's out or that's not included in B. This is the only part which is B. So the complement is the shaded part. Okay, that is for the set operations using Venn diagram. All right. And so we are done with the set operations using the Venn diagram. So let's move on to illustrating word problems on the Venn diagram. Now, if you have this, 10 kids aged 4 to 6-year-olds approached Mamang Sorbetero to buy ice cream with only two flavors to choose from. 6 chose chocolate flavor and 7 chose vanilla flavor. 3 kids chose both flavors. Okay, so how are we going to work with this one? All right. Well, for word problems like that, what you have to do is take note of what are the given information and work from it. Okay. So, of course, we know that there are 10 kids in total. 6 of these kids chose chocolate flavor. 7 of those kids chose vanilla flavor. And 3 chose both flavors. How are we going to work with this one? You have to start with the innermost part of your Venn diagram. What is this? This is your intersection, which means it is part of chocolate and of course also part of vanilla. So we can take note of the keyword both for this region. So since three kids chose both flavors, we can write 3 here. Now, when you're dealing with word problems and Venn diagrams, it's not like putting the elements inside your Venn diagram because these numbers here are not elements, but these are the number of people, kids. Let's say it's like working on the cardinality of the sets. Okay? So we are going to treat them as numbers and not as elements. Okay. Next, if we try to focus on those who chose chocolate, how many chose chocolate? 6. Okay? But 3 is already here. So for the blank region, we will write 3 because 3 plus 3 equals 6. Yes, that's how you should do it here. Next is for the vanilla part. Now, if you take a look at the vanilla, you also have 3 already written there. But we know that for vanilla, 7 of these kids chose the flavor. So to make that 7, we write here 4. Okay? Again, 3 plus 3 makes 6. Those 6 kids who chose chocolate, 3 plus 4 equals 7. And that's the number of kids who chose vanilla. 3 chose both flavors, chocolate and vanilla. And let's see if we already have the total. Let's try to add. 3 plus 3 plus 4 equals 10. So that's it. That is your Venn diagram. All right. Well, let's try another problem. So for this problem, we now have 36 teenagers in Barangay Maganda were lucky to win free food coupons from Jollibee, McDonald's, and Subway.
26 went to Jollibee, 19 went to McDonald's, and 17 went to Subway. 12 enjoyed their meal at Jollibee and Subway. 13 enjoyed their food at Jollibee and McDonald's. 7 enjoyed their orders at McDonald's and Subway. 5 loved all 3 fast food meals. And only 1 did not go to any of the stores.
Okay, that is your given. You have to work with the given. So to illustrate that, I took note of the details given in the problem. There were 36 teenagers. 26 of them chose Jollibee. 19 enjoyed McDonald's and 17 went to Subway. 12 enjoyed their meals at Jollibee and Subway. So when we say and, that means intersection. It means both or the overlapping part. 13, Jollibee and McDonald's. McDonald's 7, McDonald's and Subway. 5 enjoyed all their meals at those fast food chains. And only 1 did not go to any of the stores. So I'm using the complement of the union because if you combine all of this, that will be the union of all 3. And since I'm talking about the complement, so what remains outside this 3? Okay, so again, you always start at the middle or at the center part of your Venn diagram. So you find that part. That is the intersection of all these sets. And the intersection of all sets, here, Jollibee, McDonald's, and Subway, you have 5. You can also plot this on your Venn diagram because you know that is outside of these circles, but still inside your universal set. So you can put 1 anywhere you want. So I can put it here. All right. Then we work with the rest of the overlaps or the rest of the intersections. Okay. So we have McDonald's and Subway, 7. So this is the McDonald's and Subway part. McDonald's and Subway. Because this part is for the McDonald's, this part is for the Subway. So that's 7. But we already have 5. So we only need 2 to make that 7. 5 plus 2, 7. Next, Jollibee, McDonald, 13. Here's your Jollibee and here's your McDonald. Jollibee, McDonald. 13. But we already have 5. So that means we have 8. And finally, Jollibee and Subway, 12. Jollibee, Subway, 12. This is the Jollibee part. This is the Subway part. So 12, that means this should be 7. Okay, and we are left with these parts. So take note that if we deal with the Jollibee part first, we know that 26 of these teenagers went to Jollibee. We already have 7, 5, and 8. In total, that is already 20. So to make that 26, we write 6. 6 plus 7 plus 5 plus 8 is 26. Okay, now for the McDonald's, 19 went there. So to focus on McDonald's part, we have 8 plus 5, 13, plus 2, 15. To make that 19, you have 4. So let's add 4 plus 8 is 12, plus 5, 17, plus 2, 19. And finally, for the Subway, 17 went there. So let's try to add. 7 plus 5 is 12, plus 2, 14. And we only need 3 more to make that 17. Again, 3 plus 7, 10, plus 5, 15, plus 2, 17. So that's your Venn diagram. To know if you're doing it correctly, add all the numbers. If you would have a sum equal to our total, the given total, then that is correct. So let's add. 1 plus 3, 4, plus 7, 11, plus 6, 17, plus 8, 25, plus 5, 30, plus 2, 32, plus 4, 36. All right, so that's how you work with Venn diagrams for word problems. Thank you so much for watching. Please like and share this video. And don't forget to please subscribe to my channel. Thank you.